Hello and welcome to this lesson in quantitative reasoning. We're going to look at truth tables, specifically using the negation operation, the conjunction, and the disjunction connectives. The conjunction is and, the disjunction is or. And these notes come from your text, so there's that. And here's what we're going to look at. We're going to look at using truth tables to determine the value of compound statements. And we're only going to use the negation, conjunction, and disjunction. The conditional, or you might know it as the if and only if. The conditional, which is the if then, and the biconditional, the if and only if, will be in the next video. So, I don't know why these both say the same thing, because that's what we're going to do. So, we need to start with some facts. We've talked about the facts in other videos and in prior weeks. So the truth value of not P depends on the value of P. So this is what we call a truth table. These are like your math facts. This tells you that if P is true, then not P is false. So it just means the opposite. Hopefully that one's pretty straightforward and you know that. So a truth table is a table in which you have all of the possible outcomes based upon all of the possible input combinations. And what we do with that is, so when we're looking at the basic truth tables, like how do we evaluate P and Q? There's always just two statements involved. And you always set up in alphabetical order, left to right. Now, you could use A, B, you could whatever. Statement P, statement Q, A, B, X, Y, alphabetical order, left to right. And when there are two statements, there are four possible combinations of inputs, because P could be true, and for that, Q could be true or false. P could be false, and then Q could still be true or false. So if you look at all the paths, that would be all your combinations of inputs. So I have a path that goes true, then true, a path that goes true, then false. P is false, Q is true, P is false, Q is false. The way that comes out is if there's four statements, the first two P's are true, and the next two are false. And then for Q, you alternate. Here's the P was true and Q was true. Then P was true, Q was false. P was false, Q was true. P was false, Q was false. So you have true, 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 false, just like here. True, 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 false. And then, when you talk about the conjunction, and this will be shown in the next table typed out, P and Q. Remember, we do that symbol because we can draw our line across it, and it's an A. That's the and. This is only true if both statements are true. They have to be both true in order for the and to be true. It's like I said, I will wash your car and I will fill your car with gas. If I say and, you expect me to do both of those things. I'm not doing that, by the way. I don't even wash my own car. And I do need gas right now, actually. But anyway, true. So two true statements, a true. So what I'm putting here is, I look over here. P in the first row is true. Q in the first row is true. So this, I'm looking for the value of a true and a true, and that's going to be true. A value of a true and a false in the next row is going to be false. False and a true. And if I know I'm doing an and with these two statements, as soon as I see a false, I can write a false. I don't even have to look at both of them. I just have to see if there's a false. The only time an and is true is when they're both true. Now, when we look at the next slide here, you see that neatly typed out. So again, they put this here is the way your input columns are always going to be written in this order when you have two statements involved or four rows. When you have three statements, we'll see you get 8 rows, but for now, we're just going to be doing some stuff with 4 rows. So we can use truth tables for negation and conjunction. We could use a truth table to find something more complicated. This has 2 ands, but notice this only 2 different letters. I don't care if the letter's negated. There are 2 different letters in this. This will still be a 4-row truth table. So I would first find P and Q. Then I would negate that. I work from the inside out of parentheses, and then I'd have truth values for this in a column, and I would and it with the truth values for Q and come up with a new column of answers. We'll see that as we go on. We've done some of these in class already. So the key to doing a truth table that's not just a simple fact, like the P and Q or P or Q, is to write your input columns. The input columns are always the same. If there's only two statements, they always look like that. Statements in alphabetical order, left to right. Now, I want not P and Q. Now, I could probably figure that out in my head. Don't do that. First, you want to write a column for this. And then you'll have a column for the left side and a column for the right side. And you know with the and, if both sides are true, it's true. If either side is false, it's false. So what we do is we don't just jump right. So these are our inputs, and this is our statement we're evaluating. We can have some in-between steps, and we should have some in-between steps. Let me take a look at that. So the in-between steps would be, I'm going to write it a column for not P. So once I do that, it's easier to fill this in because not P and Q. So I'm looking at these two columns. So in the first row, it's a false and a true. That's a false. Now for the and, the order doesn't matter. So it doesn't matter that it's Q and not P if I look left to right. And the order doesn't matter. The only one the order matters for is the if then. But here, I'm anding a false and a false. That's a false. Third row, not P. And notice I'm not looking at P anymore. I don't need that to evaluate this. I don't cross it out like that when I'm doing the work. But the only thing I needed P for was to find not P. And in each row, P was true in the first row, so not P is false. Oh, this is actually, yeah, and P was true in the second row, not P is false. That's correct. Third row, P was false, so not P is true. I use that, and then that statement, that column for not P is what goes into the final. So in the third row, I have a true and a true, which is a true, and then I have a true and a false, which is false. So that's how you make it easier, rather than trying to figure out, well, let's see, I need not P and Q. Not P is false, so okay. You don't do that in your head. Write it down. Don't do anything in your head. Write down all the steps. Make a column for all the steps. So, not P and not Q. Well, in this case, I'm going to want to make a column for not P, a column for not Q, and then join them. These input columns will be here, just like that. So what I do over here, not P, in each row, not P is, so P is true, not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. Then for Q, pick up a different color pen here. So Q is true, not Q is false. Q is false, not Q is true. Q is true, not Q is false. Q is false, not Q is true. And yes, it feels like repetitive. I've already done true for Q and false for Q, and you have to do it twice. Well, that's because you want to cover each possibility of input, so you have to just finish it out for the whole column. Okay, so now I have a column for not P and a column for not Q, and my question is asking me to put them on either side of an and statement. So this is the left and this is the right. The and will be true when they're both true, and it will be false otherwise. So I can see right now I have false, because false, false. That's a false. Oh, sorry. I said, so as soon as I see a false, the and is false. This final one here, though, that bottom row is true. So not P or not Q. It's just the opposite. This actually comes out to be the same as not P. Not P and not Q is the same as not P or Q. If you did P or Q, it would have been true, 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 false. This is the opposite of that. And if you know De Morgan's law, you understand that to distribute this negation, I would change the sign in this, change the sign in this, and flip that sign, and that's what you get. But anyway, the answer to this question is this final column. And I think that's done out in the next slide also. Okay, so they did this out in the next slide. The idea is you don't have to just do it all in your head. You write down all the parts of your statement and then make the truth table for the whole thing. So this is the or statement I just talked about. If you had P or Q, that only has one case where it's false, and it's when they're both false. If I say, I will wash your car or I will fill the tank with gas, you don't tell me I lied if I did both. But if I didn't do either, you say, wait a minute, you said you'd wash the car, you'd fill the tank with gas. I don't have more gas and the car's still dirty. Then I lied. So that's the only case where you get a false in the or. You should be familiar with that by now. We've been doing this for a while. So what if I want to do not P or Q? Again, I would make a column for not P. Notice it's just the opposite of what's in P. And then do not P or Q. Now for the or, if I see a true, it's immediately true. So I see Q is true. Oh, I'm looking at these two here. I don't have a true, so that one's false. Third row, not P, Q, they're both true. And fourth row, up, not P is true, so that gives me a true. So the or is only false if they're both false. Otherwise, it's true. And that statement that's typed out down here, you see they get the same thing, but you add this column. Even though you're told you need to find this, what this tells you is you have statements P and Q. You see those two letters, so you write the inputs for them. And then, sorry, my computer wants to update, and I'm not updating it. And then you make this column here because that's part of your compound statement. Right? On to the next one. Okay, this time I did not P or not Q. And I'm just going to go to the next slide because this is the same thing over again. I make a column. So I see P, Q in my problem, so I know I have to make those as my input columns. Then I see a not P and a not Q used in the final statement I'm supposed to show, so I make columns for that. Not P is just the opposite of whatever. So you always write out these first two columns when you have two statements, okay? Now, if your statements were A and B, you would have written A, B, alphabetical order. Most of the time in logic, we use P and Q as our initial statement letters. P, Q, R is pretty typical for three statements. So then, once I do these two columns, I have an OR. And what I'm ORing together is what I see in these two columns. So in the first row, my OR is a false or a false. So that's a false. Up in the second row, I say I have a true. Third row, up this one's true. But notice I'm looking at the two columns that represent what's on either side of the OR statement. So the left would be true there, and they're both true there. So I get this. And this is actually the opposite of AND. If this were an AND, P and Q, I would have had true, false, false, false. So what we see is not P and Q is the same as not P or not Q. And again, that's De Morgan's law in practice. So if I had written if I wanted to show you these were equivalent, I would have written a column for P and Q also and shown that I got, and then I would have done not P and Q and shown that I've got exactly the same thing. So if I do this, all of a sudden this becomes false, true, 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 and I would have the same thing. You don't need, we're not quite there yet. That'll be in the next set of videos. But that's what I get, false, true, true, true. Now, if I wanted to show equivalence with not P and Q, I would have made a column for this here. And I probably would have done P and Q first and then not P and Q, but I would have seen P and Q would have been true, false, false, false. The opposite of that is going to be false, true, true, true. And this gets us to the idea of that, look, these two columns are exactly the same. These two statements are what we call equivalent. So that's how you show equivalence. You make the truth table for both statements. And even if just one row was different, they would not be equivalent. So that's kind of coming up in the next lessons, but there's no reason we can't talk about that now. All right, the next video starts to introduce the if-then and the if and only if, and those students have a harder time understanding how to, the facts for that seem to be harder for students. So be sure to watch that. Thank you for joining. I'll see you in class.